Hi, so because the exam you're about to take during exams is on the first Monday of exam time and at 9 AM, it's really not fair for me to schedule a revision lecture when some of you will be around because you come before term and others of you will arrive the day before. So I decided as an experiment this year my second revision lecture will be a video. So here it is. I'm no movie star, so I hope you'll forgive the editing snafus and poor acting ability, but it's better than not being able to come to a revision lecture at all. So what we're covering here is the relativity material from PHY101, which you had from me last semester in 8 lectures. As you know, the lectures notes are on the web, so if you need to look at the notes you can go back and get them if you haven't already got paper copies, which I handed out during the lectures. So I thought briefly I'd just cover some sort of background material from the lectures and talk firstly about space-time diagrams. So in relativity, a space-time diagram is a diagram with a vertical axis, which is the velocity of light c times the time, and the horizontal axis is position. So it's one spatial dimension and time. And events are points on space-time diagrams. So if you had an event which occurred at time 0 and at position x equals 0, then that event will be a dot at the origin on this scale. Okay, so let's put another event in. Let's put an event in corresponding to the somewhere further down, further forward in time for the passage of a light beam. So suppose this event corresponds to the passage of a light beam through the origin at time t equals 0. Then, because light beams always travel at the speed of light, that means that if at some later time an event of the light beam passing some other point is going to be somewhere up here, where we've assumed that the light beam is travelling in a direction where x increases as time increases. And so you can see that the events corresponding to the light beam moving through different positions along the x-axis as time increases are all going to line up, because the velocity of light is always a constant and it's the same to all observers. And you can draw a line through those events of the passage of the light beam, and that line is called the world line. And because for a photon or a light beam, the position is equal to the speed times the time, but the speed is the speed of light, that means that the equation of the propagating light beam is x equals c times t. In other words, ct equals x means that this line has to be at 45 degrees to the horizontal. And what about particles which aren't light beams? Well, particles which aren't light beams move at less than the speed of light. So we have, for a non-light moving particle, we have x equals vt, but v has to be less than c, because nothing can travel at the speed of light unless it's massless. So that means that we could write this as x equals v upon c times ct, or ct equals c upon v times x. So this is the vertical axis. In this case is ct, because the vertical axis is ct. That's what we're plotting. And the horizontal axis is x. So this line is again a straight line, but it has a gradient. Equal to c upon v, which is greater than 1, which means that the slope of the world line of particles moving at less than the speed of light, that is all massive particles, those slopes are always greater than 45 degrees. As the particle gets faster, v gets bigger and approaches c, and the gradient tends to 1. So this will be the world line of a slower moving particle. This will be the world line of a faster moving particle. And as I've said before, this is the world line at the ultimate speed moving particle, that is for a massless particle, x equals ct, so this has slope 1. And these are all world lines. Okay, so that's the first section about space-time diagrams and world lines. Now the other thing you can do with space-time diagrams is you can talk about how different observers observe the same physical phenomenon. So let me just clean up the board and remove this stuff, so we don't need it for the next bit.